numerical last you have done? That audible frequency range, right? $54, $30,
53. So 53.
53, I marked. And try to be on time because it takes a lot of time for this attendance. 26. Okay. So what was the last numerical we did? Please tell me.
Sir, the audible range of human.
That we finished.
22.
Have we completed
Yes,
that?
sir, finished.
Yes, sir.
Okay. Then next question. A bat emits, bat, B-A-T, bat emits ultrasound, a bat emits ultrasound of frequency 100 kilohertz. Of frequency, a bat emits ultrasound of frequency 100 kilohertz in air. If this sound meets a water surface, if this sound meets water surface, meets a water surface, what is the wavelength of reflected sound? Second bit, what is the wavelength of transmitted sound? What is the wavelength of transmitted sound? What is the wavelength of transmitted sound? Speed of sound in air, 340 meter per second. And in water, 1486 meter per second. That means, see, ultrasonic waves hitting here. This is the normal. Some part will refract, some part will reflect. Some part will refract, some part will reflect. Always you can see any wave when it's falling on a surface, some part will refract, some part will reflect, some part will absorb. 46. Right? This is too much. Now those are coming, no attendance, finished. Okay, so here we know velocity of sound is equal to F lambda. Okay, so here we can calculate, this is coming with a particular velocity, that is how much? 340 in air. Okay, 340 meter per second is its velocity in air. So it has a particular wavelength in air and frequency in air. Frequency also given. What is the frequency? 100 kilohertz. Okay, so frequency is equal to 100 kilohertz. When this wave hitting on a water, frequency of refracted wavefront, that remains same. That will not change. Frequency of reflected also will remain same. Since velocities are different, wavelength will be different. So they're asking what is the wavelength in water, what is the wavelength in air? This is a question. Okay, so first we will see wavelength in velocity is equal to F into wavelength in air. So velocity in air is how much? 340. Frequency 100 kilohertz. 100 into 10 to the power 3. From here we can calculate lambda of air. Okay, that we will get the answer You check it now, whether you're getting out, tell me. 3.4 into 10 to the power minus 3 meter. Okay, this is the wavelength. Now, refracting part, this one, going into water. We can write V of water is equal to F doesn't change, lambda of water. So V of water is equal to F is again 100 kilohertz, 100 into 10 to the power 3. Lambda of water, we don't know, we have to find out. And VW is given. Through water, it is traveling with a speed 1486. Lambda of water, if you are calculating, your answer will be 1.49 into 10 to the power minus 2 meter. So remember, when a wave is going from one medium to another medium, its velocity change, then wavelength change, amplitude. Amplitude means energy. See, actually sound wave is going like this. Okay. When it is entering into media, some part will absorb. So wavelength will be same, length will be same, but this size will decrease, amplitude will decrease. Finally, it will be completely absorbed by the medium. Okay. So here, remember, wavelength, you can put a note. When a wave is going from one medium to another medium, frequency does not change. Wavelength change, velocity change, amplitude. Amplitude means vibrational rate. Amplitude change. Okay. Is it over?
Sir, just wait.
These are all NCERT numericals only.
Sir.
Next question. A stone dropped from the top of the tower. A stone is dropped from the top of a tower. A stone dropped from the top of a tower of 300 meter height. 300 meter height. 300 meter height. Splashes into water. Splashes into water. Splashes into water. This one falls and splashes into water. Of a pond near the base of the tower. Of a pond near the base of a tower. When is a splash heard at the top? When is a splash heard at the top? Speed of sound in air. Speed of sound in air is equal to 340 meter per second. Take GS 9.8 meter per second squared. So listen, after dropping the stone, you should know how much time it will take to reach the ground. Clear? So first T1, that first you write time taken for the stone, time taken for the stone,
S by V.
To reach the ground. Reach the ground. That is T1. How can we calculate? S is equal to UT plus half GT squared. S is equal to minus 300. It's going down. U0 initially. Minus half G minus into 9.8 into T squared. Then 2 into 300 is equal to 9.8. 2 into 300 divided by 9.8. Minus minus cancel. 2 into 300 by 9.8 is equal to T squared. Now what is the value of T? What's the value of T? 7.82 will come answer. 7.82 seconds. You must check the answer, okay? 7.8. So by this time, stone reaching the water, producing a splashing sound. Now sound has to travel upward. How much time sound will reach this place? We know the formula. V is equal to S by T. T is equal to S by V. Sound has to travel 300 meter height with a velocity of how much? 340. Okay. So time taken by the sound, time taken by the sound to reach the top of the tower. Reach the top of tower. T2 we have to find out. Okay, how much is? So we have to use formula V is equal to S by T. T is equal to S by V. What is S? This is T2. What is S? 300. Velocity of the sound 340. From here we get the answer 0.88. 0.88 second. So total time T1 plus T2 is equal to how much? 7.82 plus 0.88 is the total time. Is it clear?
Yes, sir. 8.6.
So why 2 times you have taken?
8.7.
What did you ask?
So what is the T2 here?
T2 time for this sound to reach the top.
Yes,
Just
sir.
after you dropping the stone from the top, you will not hear the splashing sound.
Yes,
First
sir.
stone has to reach the water, then splashes into water, then sound produce. Then that sound has to travel and reach you back. Then only you will hear the sound. Isn't it?
Yes, sir.
So after dropping the stone, how much time it will take to hear the splashing sound? So first we calculated time taken to reach the pond, then splashing sound produced. Second is we calculated time taken by the sound to reach back here. So these two time we added. So we got final answer 8.7, right? Isn't it?
Yes, sir.
This much time it will take.
Sir.
Oh.
Sir, but if we drop the stone either in a well, like example, we drop the stone in a well, then the sound will reach us faster than if we drop it in open sea, right?
Open sea.
Yes, sir. If we drop the stone in open sea,
It
the
would
sound
reach
will
faster.
reach us.
No, it's not faster. Sound will spread. So we will not get high intensity. Loudness will reduce. But in a well, if it is falling, it is within a well, right? The tube like. Sound will be reflected back directly to you. In open sea, it will spread all the side. So speed will not change. But the audibility, loudness will reduce. Clear?
Yes, sir.
Next numerical. A string of mass, like guitar string and all, okay? A string of mass, 2.5 kilogram is under tension. That means you are tightening it with a tension, 200 Newton is under a tension of 200 Newton. The length of the stretched string, is 20 meter. If a transverse wave jerk, that means you're pushing it perpendicular to it. If a transverse wave jerk is struck, at one end of the string, that means like a guitar string, you're striking at one end. If a transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other
Sir,
end?
if I transfers
Jerk. That means holding this, just give a transverse jerk like this. On a guitar string, usually we do it. If a transverse jerk is struck at one end of the string, how long does the disturbance take to reach the other end? Okay. So
how long is the distance?
how long does the disturbance takes to reach the other end? So here, this formula I told you to by heart. I've given velocity of the sound on different media. So V is equal to root of T by M. There is a formula like this. No need to derive, you just by heart here now. Here T is tension, M is mass per unit length. Mass per unit length. That you can calculate as total mass. This is capital mass, right? Capital M. Total mass, that is 2.5 divided by length of the string 20 kilogram per meter. This is also known as linear density. This is also known as linear density. So you get mass as 2.5 divided by 20. Okay. Then we can substitute here. V is equal to root of tension is 200 divided by mass is 2.5 by 20. So 20 will go here. Okay. Then you will get answer. V is equal to 40 meter per second. This is the velocity of the wave producing here. 40 meter per second. Now, how long will it take to reach the other end? So V is equal to S by T. T is equal to S by V. That means T is equal to
0.5 seconds.
S is how much? Length. S is
Length.
equal to length.
20 meter.
20.
Yes, sir. 20 meter.
Velocity. How much you got? Velocity. I
40
told
meter
you.
per second.
40 meters per second. Yeah. That means around 0.5 second it will take to reach the other end. Okay, these are all NCERT questions. How much I can give, I am giving it. Okay. Next question. Is it over?
Yes, sir.
Yes, sir.
Yes, sir.
Next question. The equation of a plane progressive wave. The equation of a plane progressive wave. The equation of a plane progressive wave is y is equal to 10 sine 2 pi into t minus 0.005x. Y is equal to 10 sine 2 pi into t minus 0.005x, where y and x are in centimeter, and t in seconds.
Sir,
Ah.
nothing, sir. Understood.
T in seconds. Calculate amplitude, wavelength, amplitude, frequency, wavelength, and velocity of the wave. Look here. Now, equation for the progressive wave is y is equal to a sine 2 pi by lambda vt minus x, isn't it? It's a formula, remember? You remember this?
Yes, sir.
Yes, sir.
Actual general formula vt plus or minus x into plus or minus phi naught. But here looking the given formula, so like that I am writing, so here minus, so here I am choosing only minus. Okay, vt minus. Okay, phi naught is not given here, so I am not writing that phi naught also. So general formula you must know, but with the given formula we have to compare and choose the correct equation. Now amplitude, see 10, 10. We have to bring the same pattern, this one. Y is equal to A sine 2 pi into Vt minus x. Okay, but here only t is there. T minus 0.005x. 005x. Now look here. According to standard formula, along with the x, no constants. But along with the t, there is a constant. That is velocity. Isn't it? Now this formula, we have to bring in this form. How can you bring this formula in this
Sir,
format?
0.005 we take common.
You take outside. A sine 2 pi into 0.005 I'm taking outside. Then this will be t divided by 0.005 minus x. Now you see this formula and this formula are similar, analogous. Clear? Now we can compare here.
Yes, sir.
Now we can compare. A is equal to
Sir, what
this is
about that alpha? That is 0.
this is 10. Alpha, this is A.
Sir,
A.
2 pi by.
Lambda.
Yes, the value of lambda is sine.
The value of lambda is this now. Now we can write A is equal to 10 centimeter because these are all given in centimeters. Okay. A is equal to 10 centimeter. Amplitude is 10 centimeter. Then 2 pi by lambda is equal to 2 pi into 0.005. Isn't it? Two pi by lambda is equal to 2 pi into 0.005. Okay. Clear? Then velocity.
Sir.
What is velocity? 1 divided by 0.005. Clear? Then we can calculate V is equal to F lambda, F is equal to V by lambda. So these are the formulas can be used. You can try at home. Answers I will give you now. A is equal to amplitude. A is equal to 10 centimeter. Frequency F is equal to 1 hertz. Check the answers. Then lambda is equal to 200 centimeter. And velocity is equal to 200 centimeter per second. These are the answers. Okay. Can you go to next question?
No, sir, please be.
How did we get frequency? Oh, okay.
When is the preference time for you? See, it is not official. It's my own wish. What I'm telling you. See, December, 1 week, I'll give you holiday. Okay, you need some rest. Take 1 week rest. Okay, that means 10th school will close, right?
This
No,
Thursday.
Yes, sir.
This
This
Thursday.
Thursday.
Next week, complete holiday. Next Sunday. After that, Sunday comes, right?
Yes.
What
Okay,
time
sir.
it's not compulsory. Okay, I will just start revision. Those who want, because those who
Sir.
joined late, those who did not understand, those who want to support, need any support, like that. I'm not going to even take attendance.
Sir, 2 o'clock?
If all feel 2 o'clock, that means you sleep and
No,
wake
sir,
up.
not 2 o'clock, sir.
2 to 3 we can keep, right?
No, sir, not 2
One
o'clock.
session.
1 to 2, sir.
1 to 2. Okay.
Okay,
So
sir.
1
sir.
to 2, every day, not every day, alternate day. 1 to 2, I will be on Zoom. Those who are interested, you can join.
Sir,
So I will
like
start from-
sir, revision, right?
No, first I will finish the topics which I didn't give the notes. Because at the thermal heat and thermal area, I did not give the notes. You remember, I just went faster.
Yes, sir.
Yes,
So that
sir.
part I will give the notes, first of all. Clear?
Yes.
So during a holiday, sir, from which day will you start? From
Start
Sunday?
next Sunday, man.
Next Sunday.
Next
Okay.
week, this week you will have a class end. Next week you take 1 week rest. After you yourself will get bored because no work, nowhere you are going at home like that. So daily 45 minutes, I will be on Zoom at 1 o'clock. It's not compulsory for anyone. I am keeping my Zoom. Don't complain, sir is taking class in the vacation. Okay, because it's my wish to open my Zoom and sit in front of it. And it's your wish, those who want to come and listen to that. Clear?
Okay, sir.
Thing is, I was not so happy because usually my nature, I'm giving note in detail, doing all the numericals. Like that, I'm going very elaborate. But actually, according to syllabus completion, we have to finish only theory. And I send all the notes. But many students might have not copied the notes here. So such anyone wants a spoon feeding. That's what I'm telling you. More support. Come, attend the class. I will be dictating every line on the notes. Isn't it? There are many students. They need help like that. If you want. Otherwise,
So
it's
from
your wish.
chapter 1?
Not chapter 1. From where we skip the note?
Gravitation.
Gravitation.
So from gravitation onwards, we'll start. I'll give note. I will do all numericals, everything as per your pace.
Okay, sir.
So how
Yes,
much
sir.
you want to, you can finish. In between, if anybody want to skip, you can skip. If you don't want to attend, then it's up to you. So 1 o'clock, I'll be on Zoom. Those who want, they can attend the class. That's all. Right? But
Okay,
again,
sir.
after school reopening, I will not repeat because no time. January school will reopen. February will have final exam.
Yes, sir.
When
Clear?
okay, January.
So this is my plan because higher classes, we need little sacrifice. Clear? You're not small kid because you won't have a real knowledge. Now parents are happy, you are happy. Everyone score very high mark. I know very clearly, most of you just go straight away to net and getting the answer and giving to us. Because result is very exaggerating. Everyone gets out of 35, 32, 33. It never happens in physics. I know. So all are happy presently. But basic in you, that knowledge in you, less. That will make you trouble in future. So out of my
Very well,
sincerity,
this time we got good marks.
all the year I have been working that. Now only 3 more years. So that also I want to go very effectively. So this is what I'm repeating. Even I need to have a vacation. Okay, but still I will be helping you, those who want help. Okay, it's not compulsory. So don't go for any kind of complaints and all. Okay, right. So these are the answers. Okay, check this answer. Next question. A transverse harmonic wave on a string is described
Can you repeat?
a transverse harmonic wave on a string is described by yxt is equal to 3 sine 3060 plus 0.018x plus pi by 4. Pi by 4. where x, y are in centimeter and t is in seconds. X, y are in centimeter and t is in second. The positive direction of x is from left to right. It's your usual convention. The positive direction of x is from left to right.
Sir, x and y are in centimeter and
T is in second. First bit. Is this wave traveling or stationary wave? Is this wave traveling or stationary wave? Traveling. If it is traveling, what are the speed and direction of its propagation? If it is traveling, what are the speed and direction of its propagation? Second bit. What are its amplitude and frequency? What are its amplitude and frequency? What is the initial phase at the origin? What is the initial phase at the origin? That means starting, it might be little late or little early. What is the initial phase at the origin? What is the least distance between? What is the least distance between two successive? What is the least distance between two successive crust? Two successive crust in the wave. That means wavelength. What is the least distance between two successive crust in the wave? Means lambda. Indirectly they are telling lambda. So here again, this is a what kind of wave? Progressive wave. Is it clear?
Yes, sir.
Yes, sir.
Yxt, general formula, A sine 2 pi by lambda Vt plus or minus x plus or minus phi naught. This is a general formula. If it is minus, we said progressive wave is traveling in positive x-axis. Minus of minus x it become plus x. So it is going in negative x-axis. So which direction this wave is traveling?
Positive direction.
No, that's what I'm telling you. Yxt is equal to A sine 2 pi by lambda Vt minus x. This formula developed when wave is traveling in positive x-axis. This formula. If wave is traveling in negative x-axis, this will become minus of minus. So it become plus, isn't it?
Yes, sir.
So which direction is given wave traveling?
Negative direction.
Negative x-axis. Okay, when the wave is traveling positive x-axis, equation will come minus. If wave is traveling negative x-axis, minus of minus x. That become plus x. Clear? Plus x. Agreed. Now phase pi by 4. Now we can complete fast. You see, phase is equal to pi by 4. Amplitude is equal to 3. 2 pi by lambda, we have to develop from here. Okay, now only 1 minute. If it's time up, you try it yourself. Okay, next class will continue. Now yxt is equal to 3 sine 2 pi by lambda. 2 pi by lambda means, see this 0.018 will take outside. Okay, 0.18 bracket 36 divided by 0.018 into t. So Vt plus x plus this will be pi by 4. Okay, from here you. Okay, so y is equal to 3 sine, okay, 30, 60. This is the problem we did, right? 36 plus 0.01868x plus pi by 4. Even though they have given like this, it should be treated separately actually. Okay, they have given this one, but actually initial phases not. This is actually omega t plus phi naught. So keep it separately, don't confuse. Then y is equal to 3. Y is equal to 3 sine. 3 sine. We can take 0.018 outside. Then this will be 36 divided by 0.018 t plus x plus pi by 4. Okay, plus pi by 4. Now we can equate with y is equal to a sine 2 pi by lambda Vt plus x plus phi naught. This is a standard formula. We can compare. So here the question is, this is a traveling wave. It's a traveling wave. Then what is the direction of this wave? Direction is to negative x-axis. Okay, negative x-axis, that's why plus x is coming. Now we can calculate what are its amplitude. Amplitude is 3 centimeter. Then wavelength 2 pi by lambda is equal to 0.018. And lambda is equal to 2 pi divided by 0.018. 2 into 3.14 divided by 0.018. This is lambda. Calculate, then frequency is V is equal to F lambda. Okay, so here what is V? Vt. So V we can calculate. V is equal to, see, 36. 36 divided by 0.018. This is V. Then V is equal to F lambda. F is equal to V by lambda. Okay. Substitute, you can find all the values. Any doubt? Initial phase, this one. Phi naught is equal to pi by 4. Then what else you need? Yeah. Least distance between two successive crests, that is lambda. Finish it. Is it clear to you?
Yeah.
Sometime instead of sine, they may give cos. No change, everything same. Okay. Lambda answer is 3.49. Lambda. Then frequency 5.73 second to the power minus 1 or hertz. Then velocity 20 meter per second. Okay. Try this answer. I'm going to next numericals now, because today we have to finish all numerical. Then I have to start gravitation by tomorrow. Look here. Next, what should be the minimum length? What should be the minimum length of an open organ pipe? Open organ pipe. What should be the minimum length of an open organ pipe? For producing a note, N-O-T-E, note of 110 hertz. The speed of the sound is 330 meter per second. The speed of sound is 330 meter per second. Then we know an open organ pipe. For one end open pipe, this is the L. Length of pipe L is equal to, this is lambda by 4, right? Lambda by 4 for one end open pipe. For two end open pipe, it will be like this. That means lambda by 4, L is equal to lambda by 2, isn't it?
Yes.
Yes, sir.
Frequency is equal to V by lambda. Frequency will V by lambda is 2L. Okay, so this is a frequency. So this is a question. Okay, what should be the length of this pipe to have this particular frequency? This both end open pipe only they are asking. Open pipe. Okay. Length of an open organ pipe means both end open. Then we can substitute here. F is equal to V by 2L. Then L is equal to V by 2F. V is 330. 2 into frequency is 110. Okay. So answer will come 1.5 meter should be the length of this pipe. Then only you can form fundamental frequency over there. Is it over?
Yes, sir.
Next one. The length of an organ pipe open at both ends. Same like length of an open pipe. Length of an organ pipe open at both ends. L is both end is 0.5 meter. This is 0.5 meter. Calculate fundamental frequency of the pipe. Calculate fundamental frequency of the pipe. If the velocity of sound in air, if the velocity of the sound in air is 350 meter per second.
Calculate fundamental frequency of.
Calculate fundamental frequency of the pipe if the velocity of sound in air is 350 meter per second. If one end of the pipe is closed, second bit. If one end of the pipe is closed, then what will be the fundamental frequency for this? One end is closed, what will be the fundamental frequency? So for both end open pipe, fundamental frequency F1 is equal to V divided by 4L. Isn't it? Sorry, V divided by 2L for both end open pipe. Just now we have seen, right? 2L. V is equal to 350. L is 2 into 0.5. That means 250 by 1. 350, right? This is 350. 350. Then 350 by 1. That's equal to 350 hertz. Okay. Then one end closed pipe formula become F1 is equal to V by 4L for one end closed pipe. That's equal to 350 divided by 4 into L is 0.5. So 350 divided by 2. That means 175 hertz. These are the two frequencies in these two pipes. Okay. Last numerical based on beats. Based on beats.
Please, can you go back to the last slide? Just for 1 second. Yes, sir, done. Thank you.
Last question. The end of the prongs. The end of the prongs.
The end of the
Prongs. Prongs means this tuning fork, you know, these hands, they're called prongs. The ends of the prongs of a tuning fork originally in unison with. Originally in unison with. Unison means equal. This is A, this is B. Originally in unison with a fork B of frequency 512 hertz. That means initially both having 512 hertz. That's the meaning of it. Once again, the ends of the prongs of a tuning fork, originally in unison with a fork B of frequency 512, okay, is filed. That means A is filed. What is the meaning of filed? Sharpening. With a sharp rough end, just file it, okay? Like this, file it. Are filed. File means F-I-L-E-D. You understood filing? For sharpening knives and all we use it. Filing. Okay, 512 are filed. And the fork produces, after filing, this fork produces 5 beats per second. 5 beats per second when sounded together.
After 5
And the fork 5 beats per second when sounded together. What is the pitch of A after filing? What is the pitch of A after filing? So here one note you need to know. See, if you take a tuning fork, which is marked 500 hertz, for example, if you beat it strongly or beat it softly, whatever it is, number of vibration producing error will be 500 times in 1 second. If you're beating strongly, amplitude of movement will increase, but speed also will increase, but number of vibration remain same. If you beat softly, amplitude will be less. So it moves slowly, but number of vibration will remain same. Frequency will not change. Now, if you're loading it with some wax, then repeat the experiment. You can see number of vibration will reduce. But if you're filing it, then number of vibration will increase. So put a note. For doing this numerical, this concept you must know. When a tuning fork is loaded with wax, its frequency decreases. Less number of vibration will come. When a tuning fork is loaded with wax, its frequency decreases.
Yes, sir.
If it is filed, its frequency increases. If it is filed, its frequency increases. That means number of vibration increases. You know, number of beats depends on difference in frequency between the two tuning fork. So here, initially A and B are equal. After filing, 5 beats heard. After filing, you know, its frequency will increase, right?
Yes, sir.
If 5 beats heard means after filing, this frequency has 2 possibilities. Either 512 plus 5 or 512 minus 5. If 512 plus 5 means, because 5 beats heard, so this will be 517. This will be 507. What can be the frequency of this one now? 517 or 517?
517.
517.
70. Yes, because after filing, frequency increased. That's what 5 beats heard. Difference should be 5 between them. That many beats only will hear. Okay, right. So answer is 517 hertz. After filing, frequency of tuning fork A increased. 5 increased by 5. So 517. Okay, so this is a main chapter. Now portion is completely over. A Doppler effect you don't have in syllabus. Now we'll show you animation of these beats. That's the only thing remaining. The next class will start with gravitation. If I have time, I'll start now itself. Let us see what is beats. Did I show you that before?
No, sir.
So now next you want to start gravitation, right?
Yes, sir.
Yes, sir.
Sir, when is the last date to submit the practical?
Practical record during holidays, December, any day. You can bring to my house.
Okay, sir. You should bring to your house.
Otherwise, every time I have to go to school. School, if you're submitting, before school closing, you submit there. That means this week end or next week you can submit. Otherwise, school will close.
Okay, sir.
After that, you can bring to my house. Because by this vacation, I have to correct your records.
We can't make a PDF.
PDF, how? Record?
Yeah.
How then? How
After
PDF?
writing, we can.
Write, isn't it?
Yeah, after writing, we can take a picture and send.
After writing, we can take a picture and create
The
it.
record. You have to
You
bring
can take
the
a
record.
picture and send it
Okay.
of PDF.
Oh, sorry. Record you have to bring to me. Because that has 30 mark. Record 6 mark. Practical altogether 30 mark. Animations of beats. Can you see the video?
No, sir.
No, sir, you are stuck.
I'll open the screen.
So I'm going to demonstrate the phenomenon of beats. This phenomenon is used to tune musical instruments. In an orchestra, for example, the oboe will give an A, and then all the other instruments in the orchestra will tune their instrument to the oboe. Tuning is most effective if the beats, if you can actually hear the beats.
Sir,
to get beats,
actually, we can't see your
I'm
video.
unable to. I will show this. I'll show this. Actually, I'm unable to come back to this one. Zoom meeting. That became very weak. Yes.